That AP Physics test was hard. I felt like I don't even know what I felt. All these equations that I tried to memorize. I guess I did a pretty good job. But if there's only one way or some way to make this all easier, maybe I would have done better on the test. Wait a sec. Stop. Where did the physics? Whoa. Did that just happen? Did my physics formulas just turn into a yo-yo? It all makes sense. The yo-yo is physics 1. Allow me to try to explain the physics behind the physics. I'm going to briefly explain a couple of terms and things that physics 1 is compiled of. Let's start with friction. There's 2 types of friction that we use with yo-yos. One are what's called the friction stickers, right here. They're little rubber pads that, when the yo-yo's spinning, the string will rub up against and cause some friction, which will in turn make the yo-yo grab and therefore come back up. The other type of friction is in the bearing itself, the little metal spinny part in the middle. And you know there's friction because eventually it will stop. If there wasn't any friction, this yo-yo would, if I just went like that, it would spin forever. But we know that nothing can spin forever. Of course, there's friction. So eventually, this is going to stop. Let's go to something else. Let's see. Of course, there's always centripetal acceleration. If I were to throw it with gravity always acting on it, which makes it spin. Right now, it has a centripetal acceleration, which is pretty high because yo-yos are extremely awesome. So you know that gravity goes down, and the velocity is always like doing stuff. What else? Let's see. What else? Oh, there it is. Wonder where that came from. Okay, so if I were to just look at this list, there's a velocity, meters per second, spinning, but there's also angular velocity. It's always, there's a torque, because there's torque. There's kinetic energy and potential energy. Potential gravitational energy right now, and as I throw it, it has kinetic energy. Right now, as if I were to bring it back up halfway, it loses some of the kinetic, and right now it has full potential. We learned that from the law of conservation of energy, MEO equals MEF. Since there's this string right here, you didn't think I was going to go this far, huh? There you go. You didn't think it was going to go through waves. Transversal waves. No. Cool waves. Frequency. Yeah, you can't really see but the string is probably vibrating when I throw it, just very little. What else? Let's see. You probably don't think that there's velocity. I mean, there's no electricity going on. But think twice. This yo-yo actually uses electricity. You know you love circuits. And when you combine circuits with a yo-yo, you get amazing things. Don't you wish your physics teacher had the power to teach you your whole physics 1 class with merely a yo-yo? I've proven that the yo-yo is a wondrous toy, tool, and physics extravaganza. And if you don't believe me, stay tuned in for next week's episode, where I'll explain more about some of the other aspects the yo-yo uses in the physics world. See you next week.